so now let's talk about these questions. What particles not in the nucleus of an atom? Yeah, the electrons. Where are the electrons? Wow, I can't even spell. Yeah, they're in the electron cloud. There was a cloud before the I cloud and all the other clouds, and that's where the electrons were. Now, what's negatively charged? Whoa. What's negatively charged? An electron. E minus. That's not your grade. That's a symbol for an electron. If you saw E minus there, well, you don't want. That's just the symbol for the electron. I think what we're going to end up doing is something like this would be a fill-in type of question. I put things in there hoping that people would do complete sentences, but you guys are resisting complete sentences. I'll let you know when you have to explain stuff in complete sentences and all that, and when you can just fill in answers and all that. So we'll have more combinations of fill-in and multiple choice and complete sentence and like explanations. If I ever ask you to explain, I better see complete sentences. If it's something like this where it's a one-word thing, I'm not going to expect you to say, "Oh, the particle that's negatively charged in the atom is the electron." Ha 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 ha. That's a lot of extra time that you might want to use in other parts of it. All right, now how do isotopes differ from element to or for each element? Yeah, a different number of neutrons. Think of it like this. They have the same number of what? Protons and electrons, for the most part. Absolutely right. The same number of protons. But they have different neutrons. And I'm going to write neutrons, and I'll put the N afterwards because we hadn't talked about neutrons before. So, yeah, absolutely correct. All right, now, I gave you an isotope. And I gave you, where's this guy? Where are you? My brain just locked up. What? I can't find you. Oh, there you are. It's thulium. Duh. Thulium. Now, what does the 163 represent? Yeah, the 163, that's your mass number. That's protons plus neutrons. Now, I've been talking about this in geometry too. And if you are lucky enough to have me in geometry, or unlucky enough to have me in geometry in that other class, I have been telling people that you need, when there are equations, you need to write the equations. Because when you have the equation, write the equation, do the substitution, you will not believe how easier things get for you. Because then it becomes a very simple thing. A lot of the stuff that we do in here is very linear, equation-ish, with like one variable or something like this. Now granted, there's 3 different variables in here, mass number, proton, and neutron, but you're going to know 2 out of the 3. So that helps. Now, what's the 69 equal to? Okay. It's the atomic number. It's also the number of protons, which is 69, and the number of electrons, which is 69. Because the atomic number gives you, well, I can't see anything there. The atomic number gives you the number of protons and electrons. Now we can go back over here. I'll kind of move this over here and say that 163 is equal to protons plus neutrons. So 163 is equal to 69 plus n. So if you're having problems figuring out the number of neutrons and all that stuff, this is a really easy way to do it. It's a very simple equation. Write the equation out. Subtract 69 from both sides. That's 94 neutrons. So we get 94 neutrons. Now, with fluorine 23, what is the 23 equal to? Yeah, that's the mass number. So that's your protons plus neutrons. Now, with fluorine, the atomic number is something we need. That's when you go into your periodic table. Your periodic table, fluorine's up top, right here. What's the number? The atomic number is 9. Now, the atomic number is 9, and if you looked, the mass number was 19, but I gave you a mass number of 23. So what does that tell you that I gave you? An isotope. Oh, I could hug you guys. Not gonna, but I could. That's an isotope of fluorine. So fluorine has isotopes. That's all. So don't say, a couple people last couple hours are saying, oh, but fluorine has a mass number of 20, so why didn't we use 20 instead of 23? Because we're using an isotope. We're not using the actual one here. So I know 23 is equal to protons plus neutrons. The atomic number is 9. So what's the number of protons? 9. What's the number of electrons? 9. So I can go over here and say 23 is equal to 9 plus n, because protons was equal to 9. Do a quick substitution. Subtract 9. Neutrons is equal to 14. So in that case, it was not that big of a deal. And that might be a little bit difficult to see on the video.